Okay, here is another question. Solving trigonometric equation. This is a harder one. It's a quadratic trigonometric equation. We want to solve all values of theta between 0 and 2 pi is in radians. Okay, so we're going to look at this equation, and as you see, you have a cos² theta, and then we also have sine theta. These are not like terms, so we can't really do anything. We have to change one in form of the other one. So we are going to use Pythagorean identity. And if you remember, the Pythagorean identity says cos² theta plus sine² theta, that is equal to 1. Very famous, the fundamental of all identities come from this, the Pythagorean identity. All right, so we change the cos² theta to 1 minus sine² theta, and once we replace that, you notice that the equation now is all in terms of sine. We're going to go through and do the multiplication. I'm going to rearrange this right away. So this is minus 4 sine² theta plus 4 minus sine theta equals to 1. I'm going to rewrite this so that everything is on the one side. So 1 minus 4 sine² theta minus sine theta, and then the 1 we're going to bring it to the other side. This would be plus 3, set that equal to 0. We don't want a negative leading coefficient, so multiply everything by the negative sign, or negative 1, and what you will end up getting is this equation right here. 4 sine² theta plus sine theta minus 3 equals to 0. Now we need to solve that, and we're going to use quadratic equation. That's the fastest way to do it, unless you want to do factoring. Whichever you decide to do, that is totally fine. So now that we have this set up, we quickly change this sine² theta. We're going to replace the sine theta with x. So sine theta, we're going to just temporarily replace it with x. So this way we can see that this becomes a quadratic equation. And using that, we're going to use quadratic formula to solve this quadratic equation, and then we're going to come back and solve for sine theta and therefore sine theta. Okay, let's do that. So here's the quadratic formula we're going to use. An ABC, as you know, they are all coefficients of the quadratic formula and each of the terms, the A and B and C. So we're going to go ahead and do the replacement for each one. So here it is, x1 and 2, possible two solutions for quadratic equations, equals to minus b, which is minus 1. Now remember, A is 4, B is 1, C is negative 3 in quadratic formula based on this equation. So x equals to, x1 and 2 equals to negative 1, that's minus b, plus or minus square root of b squared, which is 1, minus 4 times AC. And 4 is there, A is 4, and C is minus 3. All of that over 2 times A, which is 4. Excellent. Let's manipulate, simplify. So negative 1 plus or minus the square root of, and that looks like to be 1648, that's 49, positive 49, all over 8. What are the two possibilities we have here? The first one is negative 1 plus 7, so that would be 6 over 8. Next one, negative 1, negative 7, would be negative 8 over 8, which is negative 1. All right, now that we have these two values, each of these, you set them equal to sine theta. But we don't need sine theta. We want to find theta. That's what we want. We want theta. So we have to go through and solve these two equations. So sine of theta equal to 6 over 8. That's the first set, 3. 3 over 4. Okay. All right, and then when you use a calculator, the sine inverse of 3/4, it is in radians, so make sure that it is in radians. No, it's not in degrees. Okay, so sine of theta equal to 3/4. Notice that it's positive value. So it's a positive value, and you take the sine inverse of 3/4, you get theta 1 approximately equals to 0.85. Now remember, sine is positive, right? Sine is positive in quadrant 1 and quadrant 2. So you also have to use this as a reference angle to find the second angle, which is pi minus that, minus 0.85, and that will get you 2.29 for theta 2. So these two for the first ratio that we got 3/4. The next one is the last one that you have to do, and that is for sine of theta equal to -1, and that's just straightforward. That's just one angle for that one, second function sine, and that answer will be basically 4.71, because the sine of theta will end up being in the third quadrant, and here it is. All right, so that's the solution. 3 solutions for theta: theta 1, theta 2, and theta 3. So here it is, here it is, and here it is. So this equation had 3 possible solutions, and each of them are all written in terms of radians. So because sine of theta is -1, we know that it will end up being, the angle will be 3 pi over 2, and if you use your calculator and exactly with the pi key, so don't approximate it, don't do the truncation, you punch it in, and approximately at the end you'll get 4.71, because the question may ask for 2 decimal places answer, or you can have it in exact as 3 pi over 2.